Hi guys, welcome to another Learning Electronics Repair video. I have a whole load of stuff here that came from a company called ComGo, and they asked me if I'd review it for them. So I said, yeah, why not? We'll have a look at what we have here, and then I'm going to continue this video with Carlos from Retro Upgrade, because he is a little bit more familiar with this equipment apparently, and he said he was looking forward to doing some more collaboration with me, and I really enjoy working with Carlos on videos. Hope you enjoy seeing him too. So here we go, let's have a look at what's in the box, and then we'll put this thing together, and then along with Carlos we'll see what we can do with it. Okay, so I guess you're really wondering what is in this box. Yeah, what is in this box? And that is what is in the first box. There's a few more boxes with it. So this is a ComGo Z1 laser engraver. It is the 10 watt model, I know that. So we have quite a few bits in here. We have some snazzy Ray-Bans, yeah. I'll tell Carlos to bring his own, by the way. Looks like the housing or the laser. This could well be the laser. Let's have a look what we have. If I get a bit more level, because the box is a bit slopey at the moment. Yeah, that's better. It was sloping because there was two other boxes underneath it. This came in 3 boxes. So let's have a look what we have in here. I will say I've never used one of these. I've seen 1 or 2 videos. This is the AC adapter, so we'll be needing that. And we have hopefully some, looks like we have maybe some instructions. Yeah, we have some instructions, so a bit like IKEA or something like that. It tells us how to put it together, I guess. Yeah. There we go, there's a board module. I'm not sure if this comes with any software. I guess we'll find out, or maybe we have to download that. It's in the other book. Is this just the same thing but in other languages? Yeah. Okay. So that's what's in that box. Let's have a look at what's in the other boxes, and then we'll see how easy it is to put this together. This is the second of 4 boxes, actually, not 3. So this is apparently some sort of enclosure, some heat-resistant gloves. Hey, they look useful. Fireproof cover, extension tubes, and a few other things. Sort of shows how to put that together. So we'll have to assemble that. You can see all the various bits and bobs in there. Okay, so we have that. We have a smaller box. Now this is like well, it's got some rollers on it. Yeah, so it's a little motor and some rollers on there, some connections, some more parts to it. A little user manual. This is a Rotary Roller, so we have this, and then last but not least we have a big flat box. Is this like a base or something? Yeah, it looks like it. Looks like probably a metal type base. So I'll start putting this together, which will probably take me a little while, and then we can have a look to see what we have. So this is the base part. Obviously acts like some sort of heat sink, or effectively heat shielding thing. Doesn't come with any instructions, so I think we'll just have to figure out what to do with that much, but I guess it's not going to be too difficult. Let's see what's in the other box of bits. We have a little bit of information about ComGo here. I was not familiar with this company. They make 3D printers, laser cutters, CNC machines. Basically, their mission is to provide high quality equipment to people, teachers, engineers, small businesses and tinkerers. So that's definitely me, allowing you to make stuff, digital production, digital manufacturing. Yeah, so this is what we have. A little bit of information, just a few cautions. This specifies the machine. I have the 10 watt version, gives a little bit more information about it. The 10 watts is the highest power one that they make in this particular model. Accuracy down to 0.1 millimeters. And we have a picture here, so that gives us an idea of what the thing should actually look like. Always useful when you're trying to put something together. We have a list of parts, so I'll check to make sure I have all these parts here, and then we can start putting it together. First of all, we have to put this frame together, but the manual is not very clear about this. I can see the picture, I can see that this piece goes to the front, ComGo, yeah? This piece has a ruler down the side of it, and this piece has a little micro switch. I'm guessing it's the tells the laser when it's at the end of the movement, and this is the back piece. So we can pretty much say that goes to the back and this goes to the front, but it doesn't show you where this goes and which way around this goes, and it really isn't very clear. I looked through here to try and find some photos, if that would give me some idea, and I couldn't, apart from I can see that the writing is on this piece at the front. I can't see the limit switch anywhere. So we ended up having to Google it, and I found another review, but apparently the information is on the ComGo website. So if you're interested in one of these, I will just show you how it goes together. First, we have to build the frame, what it calls the profiles. And it shows you here how to put it together with 4 screws, but it doesn't show you which way it goes round. So this one has a little micro switch on. This has a ruler marked on it. Now we can see that there's some countersunk holes here, and we know the countersunk holes should go to the outside, but we don't know whether that goes that way round on this side or this way round on this side, and I couldn't figure this out just by looking at it. I ended up having to Google it. Apparently there is information on ComGo's website, but I actually found another review and he was showing how to do it, so I had a quick look at that. So I can tell you that the holes go towards the outside end. This is the one with a ruler on it, and this is the one with the micro switch on it. And to assemble it, you actually assemble it upside down. So this goes this way round and fits in here, okay? The back piece has holes in it as well, and these holes go towards the inside end this way round, but obviously at the back, yeah? So that's how it all goes together. So let's get this put together. My bench is just about big enough for this, and then let's see how it looks once it's assembled. I have it partly assembled and realised again I have it wrong. This goes this way round with the holes to the back. So it's not difficult to put this together, and if you have access to the internet, it's easy enough to find the information. But I must admit, it would be so simple to make this manual useful, just to show you which way round the bits go. It seems so obvious. I'm not quite sure why they did that. Okay, we have internet, but what if I was somewhere where I didn't have access? Anyway, I'll put it together. Okay, that's assembled. Yeah, you can see the back and the front is too large to fit into my field of view of the camera. And it's not difficult, but just a little rant again. If you're going to make a manual, make the manual that shows you how to do the job. Yeah. Otherwise, just put a link to your website and say you've got to go online to find out. I just don't see the point of this. Okay. Right, let's see what the next step is. So it's basically to put the gantry on. So this needs to go the other way up to do this. This is the bottom. That's fairly obvious because the word ComGo is on the top, yeah? And to do this, I need to just wedge something under here, possibly just to protect the switch. It comes with some of these bits of plywood for playing around with the cutter, I guess. and it just so happens there's enough of them just to rest it on. Yeah. So we can rest that on there, and now let's just go into the next part of it. So the next part, take out the X-axis kit. Well, I know what it looks like, there's a picture of it, and embed it into the gantry along the V slot of the Y-axis. Sorry, Y-axis. And the next step, okay. Take out the X-axis kit. Well, I can see what it looks like, and I've got something that looks like that. That's fine, yeah. And embed it into the gantry along the V slot of the Y-axis. Doesn't mean a lot. I mean, obviously I can see it goes on the back of here from the picture. So we can move this forwards. In fact, I think I'll actually put it sideways on my bench to make it a bit easier to see. I've got a little bit more room in this direction. One thing's for sure, to put one of these together, you need some space, okay? So this is the X-axis, I think it called it. And basically, this slides on to here. But yet again, I had to refer to another video to understand how to do it. And once again, I found myself referring to another video. So basically, this wheel goes underneath the bar, and these two wheels go on top. And it kind of like fits like that. And the same on this end, if we get level, a bit awkward. It sits on, yeah, so that's it. It's on now, it's running on the wheels, okay? So that's how that fits on there. Okay? I mean, maybe it's just me, but I'm used to putting IKEA stuff together, and I don't have a problem with that, yeah, with the instructions. Anyway, never mind. So that's on there. At least the information is on the internet, fortunately. So use two M5 times 8mm screws to fix the motherboard cover to the front of the gantry. So this is where, on here, and I'll just have to slide it back a little bit, this is where the motherboard cover goes. But once again, it's not quite as simple as that. You have to effectively set the tension of this first, and this again is referring to their website and to another video. So I think we can say for certain now the instruction manual isn't really much use, and I doubt I'll continue to try and use it. So this is what sets the tension. It's this bolt here, but that seems to be running nicely to me through there. It seems to be working just fine. Okay, so I'm just going to follow the instructions, which is basically to make sure this bolt is tight. So for this we need to spanner on here. Comes with all the little tools that you need. That's too small for that, but I'm sure there's a large enough one. No, that's also too small. Well, mine doesn't seem to have the correct Allen key for this, but oh, I tell a lie, so it does have. So yeah, that's tight. That's pretty tight, that is. Just try the other one as well on the other side. And again, you can see this, I guess, is the Y-axis. This is rolling on here, yeah? You can just make sure this one's tightened up. Yeah, that's tightened up. Okay, so that's how the roller works on there, and it's running smoothly, I find. Yep, because it's upside down, I can go this way as well. Yep, that all seems okay to me. Right, next step. You can set the tension of these by adjusting these little bolts. I've just tightened this one slightly, but I think you can probably even hear it. You can hear it moving the motor, I think. That feels nice to me. That feels, and this feels like it has a nice smooth motion as well, so I'm fairly happy with that. So this motherboard box, well, this goes on the front of this, where we have the, just turn it around, this is where we have the ComGo title, if you like, and this is where the motherboard box goes. So we'll just feed this under here, and then this has to go onto here, which I guess will just go this way round because the cable's going to that side. That looks reasonable. And we attach this with 2 more of these Allen bolts. These are a little bit fiddly because there isn't much room down there. I've managed to get that one in the right place, and hopefully this one's going to be even worse because of the cable here, which is also in my way. Let's see if I can actually get the screw to go in. Nope, they definitely made this rather fiddly to do. Yeah, it's kind of like stuck in there now. So yeah, it's in the hole now. So that's a bit fiddly as well. I mean, it's not difficult to put this together, but it's particularly, I wouldn't say it's hard. How can I put it? It's like harder than it ought to be, harder than it needs to be. That seems to be the case. Let's just get this to start. Allen key is a little bit short, doesn't help very much. This is what I mean about it being harder than it needs to be. Yeah, so like this, I can't rotate it all the way around. Okay, it's not a very long bolt, fair enough, it won't take long to do, but it just doesn't seem as easily thought out. Like they didn't think about it. That seems to be the best thing I can say, like they didn't really think about it. Just give you a longer one of these, yeah. Anyway, it's in. And the same this side, again I'll have to mess about because the Allen key isn't really long enough for the job, but eventually I will get it. There we go. Again. Comments below, guys. Should I bitch about it or should I just get on with it? That's the question. Okay, so that one's in. This is fell out from somewhere. I'm not sure where that came from. We'll see. We'll see if we figure out what that is. It's like a little springy thing with a couple of little ends on. It's not broke off something, but it's kind of like it fell out from something. Okay, got that. Let's carry on. I think the feet might be next. Even putting the feet on isn't obvious or easy. So it says the mount with 8 bolts, that's 2 bolts per each one. And it's fairly obvious it goes on that way round for each one, but there's only 1 bolt hole. So what you have to do is you get some of these things that come with it. I've pretty much given up on using the manual now. It just isn't giving me the information I need to actually assemble this. I have to ask myself why they even bothered to produce the manual. It just isn't worth the paper it's printed on. Sorry ComGo, but that is my honest opinion. And then this thing here slides into here, so that little nut thing slides in. Now you can get the second one and put it on there. Yep, and then you tighten both of them up, and that's attached to the foot, just a slightly smaller Allen key. Yeah, get nice and square on the unit, tighten it down, and then it's the same for the other 3. Yeah, it's the same for the other 3. Okay, that's in there, tight-ish. Again, this one you can turn the Allen key around. I'll give them that, just about. Again, tighten that one. Tighten this one. Yeah, and then go on to do the same with the other 3. So, same thing. Not difficult. Please tell me how to do it without me having to look it up. Next step isn't even in the manual. I think they've given up. Little cable holder goes here, which we stick down with this double-sided sticker. So, yeah, can go in onto here. Yeah, slide it into position a little bit, there we go. And then I find out that this cable's supposed to go through here, and I've got it going through the other side of here. So now I have to take this back off again to feed it back through here to feed the cable. And that's even with the information I had, yeah. So this is where I've given up with a little Allen key. Now I've got my own Allen key out, because having done this once with the short one was okay. Having to do it twice because the instructions weren't very clear is like less than okay, yeah. So now I'm just going to get a long enough tool to do it in the first place. Okay, okay. I mean, don't get me wrong, guys, this thing is well constructed from what I can see. It's just not well enough documented. Okay, there we go. At least with a long enough Allen key, you can see what a difference it makes. What a difference an Allen key makes. Okay. Yeah. Not really a problem. Yeah. Okay. Next. Well, yeah. I'm not sure if both these wires go in here. I don't see. Well, we'll see. We'll see. I won't click it on just yet until I figure out where this one goes. But at the moment, they're both coming through here. Well, apparently both wires do go in here, so we can clip this down. Should just clip, I guess. Oh yeah, went with a click. So that's that done. Now I've got to put the rubber bands on, the timing belts. So let's have a look to see how these go. Yeah, if we get into a position where you can see it, we'll try. So it's standing on its feet now. So basically the timing belt fits in this groove here, and it goes, let me see if I can show you. I can show you. So the timing belt, I'll just try and stop this falling over while I show you this. It comes in through here under this wheel, goes over the top of this pulley and under the other one. So that's how it actually goes. Let me see if I can actually get it, maybe just by flexing it up slightly, or I'll have to use something to just pull this back up. Okay, I'm using tweezers. I'll show you how it goes in a moment. So I'm just using tweezers at the moment just to get it into the right position over this little pulley. Yeah. Then it goes back under the other wheel on the other side. So it goes back under this one. If we can get it to go. Bit fiddly, these guys, I mean. A bit fiddly, but I think it's going. Yeah, it's coming through now. I'm sure you can see it. Yeah, so that's how that actually goes, and then we can kind of like feed the thing in, I think. So if we get hold of this end of it, yeah, it's pulling through now. Yeah, so I can just show you now. We're going from the side how that actually went, in case it wasn't clear, but I think it probably was. So you can see the timing belt comes under the wheel, over the top of this one and under, okay. These attach with some little square washers, which I'm just trying to figure out where they are in this kit of bits. Okay, thought for a moment they were missing, but they're not missing. So we have the little square washers, and we have the 4 remaining screws. So to do this, if you look on the belt, I'll probably have to get a torch so you can see it. My bench is not quite big enough for this sort of work, but can you see there's like a little indentation, it's a little mark. So that's where the bolt goes, and the same on the other end. So let's put the bolt in first at the front. The little washer thing, yep, slides in under there. So that can be lined up with a circular mark. This then goes into the little square bolt. And once again I can just line it up onto the mark there, and we can tighten this up. Okay, just keep it flat. It's tending to twist slightly. Okay, I have the band there, yeah. What we now need to do, turn this all around, get a bit of tension on this. Now that's actually gone off the end there, so I've obviously put this one in too far back. So again, we need to just loosen that and centre it up. So we just loosen that. Pull it more this way. It actually sits better now. I think it was hitting the bolt that goes through here before, which it wasn't quite level. Okay, get that centered on there. Now we have enough space. You can probably see, I hope, the little mark, little where the bolt goes. So again, we'll tighten this end up. I'm thinking it'll probably sit flatter now than it did before. Okay. Yeah, that's definitely got a grip on it. Just doesn't tend to sit very flat. I have to hold it. Now we put a bit of tension on this. I can feel it riding nicely. Okay. We want one of these square washer bolts again. Sorry, washer nuts probably. There's an old joke from the 70s or 60s. And it probably only works in English as well. But anyway, the story goes that a guy escaped from the lunatic asylum, went down to the local laundrette, forcibly had sex with the women who were in there and ran off. And the headline in the paper said, "Nuts, screws, washers and bolts." The old ones are the best, eh? Nuts, screws, washers and bolts. Was that one worth resurrecting, or was it still known of? Okay, I've got a bit of tension on that and it seems to be tight. And the little sprocket thing here is running on it nicely. So now we have to do the same on the other side. Well, we're getting somewhere now. These little plastic covers just go on the ends, just covers up the sharp edges there, makes it look nicer basically. So one of these on each corner, and then we have to set up the laser. So to do this, we take the cover off, and this is where we attach our laser module, in this case the 10-watt laser. So we'll just have a look, make sure I know which bolt hole they came from. Yeah, it was those two. Again, there's more holes in this than you might have expected. Okay, that comes off. And then this is where we actually attach the laser into these slots here. So we'll get the laser module, which is here, and we can take a look at it. Here we have it. Engraving laser. Avoid eyes and skin exposure or direct radiation. Okay. And this obviously fits into the holder one way or another. I'm guessing it actually goes on the back. Yeah, it looks like it must go on here. And there are some slots. Yeah, there are some slots there where we can screw it on. I've attached that. There's only one position that will go on in. It's a little bit loose at the moment. So we need to get this parallel with the actual laser if we can. So I'm going to actually lay it down on the bench, see if I can get it to sit flat on it. And it doesn't quite, because it's kind of like recessed slightly on it. So I think I'm going to have to kind of like, yeah, if I've pushed it to one side or the other, it kind of like hits the end stop of this, yeah. So I've kind of like, I'm using my fingers really to feel when it's level. No, I think we have to go down to one end. That way we can say with certainty it is quite level. Yeah, that way we can say it is sitting flat. So we'll just hold it against the bolts. And we can tighten these up. We can always adjust this later, it's not really a problem. I'm using my fingers actually to feel when it's in the basically central position on there. Okay, that feels quite level to me. Okay, we'll go with that. Okay, so that's on. Now, this fits into here, and you can adjust the height of it, so you can actually adjust the position depending on the thickness of the thing you want to actually engrave or cut. So I'm going to put it lowish down at the moment. I mean, that's at the bottom, but that will allow me to raise it quite a way. So I think I'll use the top holes on it, and then we can set it to the position we want, but we can adjust these if we want to raise it any higher. I mean, at the moment, the highest it will go to is here. But we can use different slots to actually position it where we want, yeah? In fact, we don't want it to hit the board. I'm going to use that one. Okay. So I'm going to use these slots for now. And we can have a play around with it. These are obviously meant to be moved. I mean, they could have made this thing a bit longer so you've just got the full range of adjustment, but I guess that probably isn't particularly important. It doesn't take very long to set it where you want it anyway. Okay, so we'll put the things in there. We can just set it for now. Okay, so that's the laser mounted. Now I'm going to attach the cables. We have two plugs, one marked pulse width modulation and one marked power. Now the two plugs are identical. I don't know if it would damage the laser by putting them on the wrong way round, but I really wouldn't like to find out. So we can pay some attention. This is the power lead. It's marked as power, and that's marked as ground and power. They'll only go into the socket one way round, but you could mix them up. Yeah, so this is the other one marked PWM. Okay, they're marked, but honestly, why not put them with different connectors so you can't mix them up? I mean, I tend to go on the basis like that if anything can go wrong, it will go wrong. I mean, maybe you're not going to be disconnecting this very often, so maybe it isn't an issue, but I would have liked to see something that stops you mixing them up. Anyway, I've put them in the right way round, so I think that's assembled now. And now we have a few more wires to attach, so I'm not sure how this will come into shot, but there's a connector here and that goes in underneath this motor. Sorry, it's a bit blurred. I'm having to hold this at an angle. I'm sure you can see what I'm doing. So that one goes in under there, and then we can turn this round. It's quite a substantial piece of equipment. And we have this one on this end, and this quite clearly goes into the top. So that's those two in. Hopefully that's all the connections actually made. No, I was slightly wrong. There's one more connection, which is the little limit switch, the thing here. And this time I will have to focus it a little bit. Yeah, you can see it now. So this is the little limit switch that sets the end of travel, and this again has a little plug to attach. So we'll just attach that, and I am now convinced that is all of the cables attached. So now we can just make sure that this moves freely, that the wires are not going to get trapped in anything. So this is actually moving. You can see the motor rotating. It just hit the wires under here. These are just maybe moving somewhere out of the way. So that's running nicely. And then this, yeah, it's hit the limit switch at that point. Okay. Yeah, that's just before the laser hit the frame actually. So that's why that limit switch is there. And it will reach the far end. Okay, so that's running nicely. That is constructed. Now what do we do with the other bits? Because that's effectively is the end of the instruction manual and also the end of the video I was referring to. Well, we do in fact have this kit. So this is some sort of cover by the looks of it. Fireproof cover. One-sided instructions. So let's have a look. I think this is a bit like putting together a tent, basically. These things, you know, like they just slot together, and it's kind of like showing me some instructions here. So let's see how much of a pig's ear I can make of putting this one together. Well, some of the tubes are marked W, there's 3 of them. 4 of them marked H. Another 4 marked L. I'm strange I've got 3 W's, but who knows, we'll figure it out. So we have to look at the instructions, and they marked L, H and W. So that might give us some ideas. Extension tube, L equals W. 1. Insert the L and W tubes to extension tubes and put the 3-way joints on both sides of the H tubes. Okay. Well, there's an L. There's a W. Okay. And an extension tube, so maybe kind of like this goes together somehow. Well, that's got a thin end of it, so that inserts into something. I think once again I might need the more in-depth instructions, unless I'm just being a bit stupid, yeah. Yeah, it's kind of coming together because I have 3 of these W tubes, 4 of the L tubes and 7 extension tubes, and these things quite clearly fit onto these. So we have, which then look to be the same size as the L's. I can't understand why. What's the difference between an L and a W? Yeah, they're basically the same. To me, look the same. Okay, well, we've done it. There's the L's and W's together. Okay. Now, assemble the set of supporting iron pipes with a 3-way supporting frame. L's and W's obviously different, and that's where these things come in. Oh, and then we've got H's. I see. That's some sort of 3D jigsaw, isn't it? But I think it's probably doable. So this is a W. Yeah, look at the picture. Look at the picture, eh? Look at the picture. That's a W. So this goes into one of these somewhere. Probably that way. And then this is an H. So this, yeah, into there like that. Oh, I see. And then that's the kind of an L, which goes that way. So the L's and W's look the same, but they're different somehow. Doesn't really matter which way round it goes. Well, it shows the L at this end. So that goes into there. And I guess we do the same at the other end. Then this has like one sticky out bit, which is thin compared with the other ones. Why is that? Oh, I see. Yeah, the sticky out bit goes towards the H. Goes that way. In fact, that was visible in the picture. I'm not sure if you can see it, but it's there. So you can see the sticky up bit goes to the H. This is maybe not quite so difficult. This is the owls. And then the same on the other side. Yeah, that was very much like putting a tent together, which I've done before now, so wasn't so difficult. It's a cover for the laser, obviously. Has a funny smell and a feel to it. I think if you have like a latex fetish, you'd probably like this. But otherwise, not sure if I like touching it much. But anyway, I'm absolutely sure that this will do the job. So that's the cover. It just attaches with a couple of bits of Velcro. It's quite simple. Has a vent, which I just put a cover on at the moment, which has a vent for fume extraction. So that's the cover. So that just leaves, well, the question of the leftover bits in the other box. So let's have a look at that. So these are obviously samples for engraving or cutting, so we know what to do with those. We have, well, I'll zoom down with some sort of USB. Yes, this clearly a little USB adapter for various types of cards, and obviously this card will fit into it somewhere. 8 GB. Yeah, that's not an elastic band, it's just how it is. This has got to go somewhere in this. Not the right way, possibly not the wrong way around. Try it that way. It's got a little notch in it, so only go one way round. Well, it doesn't go that way. It doesn't go in there. Oh yeah, it clicks in there. I was right first time. So that's obviously maybe our software or something like that. I'm not really sure exactly what's on that. We'll stick it in the PC in a minute and let's have a look. But we have that. We have this. Doesn't say what it's for, what it does. We have a couple of these, which came with the actual laser. It wasn't mentioned in the instructions. Charging wires, obviously. We still have this, which I'm a bit concerned about. I don't know where that's come from, unless it just happened to be on my desk and I hadn't seen it previously. That's rather. Shall we have it? What do you think, guys? Yeah, I have to put them over my glasses because I can't see well without my glasses. Everything looks green, I'll tell you that now. Everything looks green. You're not feeling you have in the morning when you had far too much to drink the night before. That's what that feels like, yeah. Everything looks green, okay. Yeah, that feeling. Power lead, obvious. USB lead, obvious. So that's what we got kind of like left over in the way of bits. And then we have this thing that, honestly, I'm going to have to look up. It says it's a ComGo Rotary Roller. So I'm going to have to look this up to see what it actually does. I guess I was showing my ignorance there, really. So I had to look it up. This is for effectively engraving on things like tumblers and glasses, effectively circular things. So this sits underneath the laser. It attaches to the motor wires instead of the XY thing that moves, and then the laser can print onto something and rotate it while it's doing it. So we have that to play with. I can see how to connect it. So I think now we'll just have a quick look at the completed unit, and then we'll carry on with Carlos and we'll have some fun with it. Well, I did put that USB in my computer to see what actually is on it, yeah? You're probably thinking, Rich, you should have done this in the first place. Okay, so this is what's actually on the USB. We have driver files. We have engraving parameters. These look like the documents to me. 10 watt laser parameters. Let's have a quick look. Yeah, some information. power settings, speed and such like. We have installation guide. How about that? Yeah, the installation guide. So I think now actually probably I really should let them off about the manual, though I haven't read it. I'm assuming this at least is a little bit more in depth. So we have that. Laser GRBL control software, light burn control software, user manual, materials library. Oh, these seem to be sample images we can play around with, but we're going to find something much more interesting to do with it than this. And definitely some electronics repair and electronics project related stuff we're going to do with this. And video, link to the video, and this is where you can actually find out how to put it all together. So if I'd done this in the first place, it would have made my life much easier. Okay, let's have another quick look at the unit itself. Okay guys, I've repositioned the camera over the bench so it fits a bit better into shot now. Looks like a very nicely constructed piece of equipment, I will say that. It takes up a fair amount of room on the bench. It would certainly take up a lot of room with the cover on. But I have enough room to use it, so I'll get the software set up, I'll get together with Carlos, and we'll give this a go.
Hi guys, Carlos from Retro Upgrade here. I took home the machine. Some time constraints stopped us from doing it together, but it's fine. I'm just looking over the machine. Don't really like the hanging cables. Could be fixed with a chain, a 3D printed one, maybe a future video. Just checking over the limit switches so they work, because if it crashes it doesn't sense the limit switch, it just keeps going. I found where the metallic piece goes. It's a part of the limit switch. This is the software I tested the machine with. It's light burn. You get a 28-day trial period. It's really worth it. It's like comparing, if you compare it to Laser Cutter, that's free. It's comparing Paint to Photoshop. It has way too many features to actually be comparable. Laser Cutter is fine if you're just going to raster images or cut out simple shapes. But if you're going to layer stuff, you need laser burn. Okay, here I'm just taking my COM port. Because I have a 3D printer, I have actually two of these devices. And it's on COM port 6. It doesn't detect the machine automatically. So I ended up just making a custom profile. You have to choose GRBL as the firmware. Choose the USB. And just put in the dimensions and the name you want for the machine. In this case 400 by 400. And I chose the machine name like the actual machine, just so I don't get confused with my 3D printer. You should choose front left and auto home for most hobby machines that have home, otherwise skip the home part. You actually have to change the COM port manually on the bottom as well, because it doesn't remember it. I press the home button here and it goes home. And it didn't crash anywhere and didn't make funny noises, so that's fine. I found this box. I didn't have any wood laying around at home, so I stripped it of its metal pins so the bottom falls out, and I'll be using this for testing. It's balsa wood or compressed wood. It looks like the IKEA stuff. I have tried it with balsa wood as well and it works fine. It's actually the same power requirement. I sanded the entire bottom. It still has some discoloration, but that's fine. It's just for testing. Okay, so I go through the little box. I did a few test burns with it before I started recording. This is 25%. The one on top is 50. and the one on the bottom is 100 at 5,000 millimeters a minute. It burned really deep on the 100, so I will be using maybe 25. This is a test I did with Richard, and it turned out great. But the laser power was a little too high, so it actually burned through. So it almost cut through. But it's capable of some nice accuracy. Okay, so I start by making a box roughly the same dimensions as the piece I'm going to be using. This is just for my own reference. I usually draw stuff to reference. So this box is 31 by 19 centimeters. Don't forget to untick the padlock so it doesn't keep the size after you make it. Okay, so I'm just making the corners. It has 4 centimeter long corner or parts missing on each corner. So it's a little, let's say, chamfer, I think it's called. I'm just recreating what I see. This is not necessary, all pieces will be different, but this was just so I keep the laser inside the wood area. It has a lot of functions, just like if you compare it to Illustrator or something. It has the mirror modifiers, the raster modifiers, it can also group stuff together. It seems to be working in vectors. That's good because vectors are lines and nothing more, so the laser can actually follow them. Here I'm using the mirror commands, horizontal and vertical. Now I group the entire thing together just so I can choose it at will, and I will be excluding it from the actual burning part or the printing part. My girlfriend wanted this picture printed on the piece of wood, so I did. Happy wife, happy life, I guess. So if you hold control, you can scale uniformly, just like a lot of applications. I'm trying to center it here, and I know it snaps, but it won't snap. But it's because I disabled the layer for the box. So up on the right, I'll notice in a second that it's ticked off. So it doesn't actually snap if you have it disabled. So you have to re-enable. There we go. And now it snaps to the middle. So you can actually snap it and then just disable, and it still stays there. So that's really good. This means that reference pictures or stuff like that actually help with this application. I just checking over. You right click and press image properties, I think it is, and you image adjustment, sorry, and you can adjust the output, and this on the right side you can actually see exactly what the laser does. I was recommended from another user that I need to use a brighter image or a more contrasty image to get better results with lasers. So that's what I'm doing. I'm just making it a little more, let's say, sharp, because the other one is really smooth and you won't get that kind of detail using the laser. But actually it's pretty impressive what this thing can do. And that looks good enough for me. It has a lot of detail, it's sharp, so let's go for it. I just thinking that it's too empty on the side, so why not go all out? You can use the preview button, but it's actually worse than the image adjustment tool because it shows all the move commands in red and it just makes it blurry. It is useful because you can press play and see how it will work. I just noticed it's missing a corner, so I'll go for our next one. This vine looks nice. I'm just going to use my favorite copy paste tool, Screen Presso. You can edit, crop everything inside the copy paste, and you can just drag out from it because it makes images of everything. Not sponsored. Okay, so I learned something important here in a moment. I tried to do the preview thingy, and it just fails on one of the sides. And the reason is actually quite surprising. It does not cut off the corners if it's outside the printer. It just flat out removes the entire thing. So if it's an image, you have to be very careful to keep all the corners inside. So it makes it really hard to put stuff right at the corner. This actually looks like it's inside, now it's outside. So I thought it would just ignore the things that are outside because it's white, and white is not actually burnt in. But I was wrong. So I'm going to just adjust a little more, so I'm happy. I went into the image adjustment here as well to get a little more contrast out, because I thought it would show it like it does now in some kind of just black, but it actually has some different shades, so I want to see if it can keep that shading, and after a little tweaking it looks nice. And I removed the old one and copied over the new one, so it keeps the settings. If you hold the control key again, you can flip it around with the resize tool, and it does it uniformly in one axis at least. So I press the screen preview button and something's missing, the left side. And that's only because it's outside of the machine's actual active area, so it can't reach there, so it just flat out deletes the print, or that part of the print at least. So if you have a complex shape and one of the lines just crosses out, you will not be able to print it, so be careful with that if you're using it, because if you forget to do the preview, you may miss it. So I'm quite happy with this, but I wanted to try the cutting capabilities as well of the machine. So I was thinking of maybe putting in some clouds and stuff, but the kid ran to me at the bench, and she wanted hearts. So I went to hunt for hearts, because I just want an outline of the heart, because I want to cut it out. I have to find a non-rastered image to make it easier for the application to find. So it has to have a solid color, and it's a lot easier to get nice edges from the application. If you've used Illustrator or Inkscape, it does the same. The blue one would have worked as well. So I put it in, just opened the image and used my print screen tool again, and just took a random print screen here, and then actually I go in and fix it with the crop tool. It gives you more control. This is so I don't have empty space when I do the trace image command in the application. Usually helps a little bit. Okay, so I pull it in to the application again. I resize and position it. You use all these modifiers on the sides of the, or tools on the actual image. And there's probably good. I'm not that artistic, so sorry for the low quality image or idea. I'm better at actually designing and making stuff than I'm and then I'm at drawing or planning out stuff that it needs to look good. I just make it so it's actually functional and I don't care anymore. So if you right click on an image, you can trace the outline. There we go. So you can't see the blue line, but there is a faint blue line around it, and it's created a line profile in the second layer. I put the hearts on the second layer as well. You click on the bottom, you see the colored squares. You just click on one of the layers. And then we have two hearts, and the reason I put it on another layer is so I can actually change the power outputs for different layers separately. So it does the first pass first. I found the documentation for ComGo here, and it has some recommendations for how much power to use. I'm looking at the 5 watt right now. I was a bit confused. I go over to the 10 watt now and find the power settings. I ended up using 25% of laser power for doing the rastering and 5000 millimeters a second. And for the cutting, I did 100% power and 250 millimeters a second. That was okay, and actually I think the power is actually a little overkill because it got a little charred the edge, but it looks nice. You'll see it in a moment. You can double click on each layer and just set up the power and speed for each layer. I'm actually quite happy with the result that follows now, but I'm a little pedantic when it comes to this thing, so I just looked it over like 5 times before I actually printed it. I cut out most of it, and you can use the frame button to actually see exactly where it's going to burn. So I framed the entire thing, and I was a little off, so I moved it again, then framed again. I just cut those parts out. So that you see here, I'm just repositioning it. And when you frame, you can do it circularly or square. In a square, you can also use the little pointy thing that looks like it's from out of Google Maps on the left side, and you can actually reposition the head wherever you like on the image, so you can see exactly where one part of the image will be. Okay, that looks good. It's time to press the play button, and that starts the laser. Don't forget to put on the power and have the USB connected. If you don't have the power or USB connected, obviously the machine won't move. And if you only forget to turn on the power, the machine won't move, but it will detect in Windows, so it will look like it's on. But it's kind of noisy, so you will notice. I'm just still rechecking. It's still a laser. I still want to be careful. I did this without the shroud on because I needed to record. It doesn't make for a good video if I record shroud that doesn't show anything. This is real-time speed, and actually I'm pretty surprised of how fast it can burn in and make a really solid line. This is essentially a dot matrix printer that prints a dot every time it goes over the point it's on. Look, if you look here, it actually blocks out all the laser light. I think these are really good, the glasses that come with it. The recommended ones are red for some reason, but that shows the laser light, so some light gets through. Now I put up a time lapse just to show I don't do any tricky business in the background. I'm using the ComGo backplate as well, or the bottom plate, so I don't burn a hole in my table. You use the honeycomb side to actually mitigate how much it can cut underneath. The laser is reduced in power a lot after it goes through the material, so that's good. I put a time lapse on the camera because yeah, this was over an hour to do the entire thing. It's quite big, so 31 by 19 is large. I am hoping this turns out good in the video. It's a little laggy on the editing software, so we'll see. I slowed down the video here so you can actually see the steps when it cuts. I think I cut it a little too early, but fine. You'll have to deal with it. The idea was we were actually doing another project with this laser, but it turned out not being powerful enough to do what we wanted it to do. And that was cut copper clad. We'll talk about it later when I do the summary with Richard. Don't want to leave him out. It was his idea from the beginning, so that's good. The machine actually performs quite well, and I'm quite surprised on how well it performs. Here it starts cutting. It smokes a little bit, so it would need an air assist. It's a little nozzle you put on and with an extra air pump, so it removes the smoke, so it can cut deeper and cleaner. But it's still quite clean, considering it's my first cut. And the heart actually just drops out. I don't even need to remove it or snap it out or anything. On the other side was a little tighter, but still worked really well. This machine can make you a fair bit of money if you know or have an audience to sell to. You can make trinkets really easy, you can make mugs. It comes with a roller attachment. I never got that to work, but it's just a settings thing, I think, in the software. So they just fall right out, and the quality is really good. If you the discoloration you see on the actual image is because it was dirty or discolored from the beginning. So actually the parts that weren't discolored just look amazing, and the details are really good. Okay guys, so it's time to sum up everything we learned about this machine with Richard. Here we go.
So here we are together, guys. As you saw, we both did parts of this video separately, Carlos and myself, and now we're here to sum up about the machine and our thoughts on it. So Carlos, you've used it mainly so far, so over to you. What's your opinion of this machine?
Yeah, so I've used it the most part of the week, and it was really nice to work with, actually. It's worth the money, just considering what you can do with it. You can do so much with it. You can etch glass, you can etch acrylic if it's not transparent, because this laser doesn't handle it very well, but otherwise it works really good. I cut some wood in the video like you saw before, and etched it as well, and that's actually the most useful thing you can do with it, because you can do enclosures and stuff. We're actually going to make a video soon making an enclosure for the milliometer.
Yeah.
Richard made in the past video, and it will look quite good because you can etch on logos, and you can actually make a perfect sized holes, so you don't need to use a bandsaw or anything.
So we can use this in our electronics projects, to be quite honest.
Yeah, and you would assume it's not useful for a hobbyist that just does electronics, but you would be wrong, because you can actually do a special project that Richard had in mind from the beginning. We actually tried to etch through copper first on
a PCB.
PCB, it doesn't have the power enough to actually burn through the copper. So that idea went through the window, but it actually can burn off the solder mask. So we had the idea of making maybe a copper clad with an etch resist on top.
Yeah.
Maybe a spray paint or something, and then burn that off, and then Richard is going to get some, what's it called, ferric chloride?
Yeah, yeah. Well, in fact, let me zoom down and show you what we had in mind, what
Yeah.
we're doing. Yeah? Yeah, so as Carlos said, we can use this for electronic projects as well. When I was first asked to review the laser, one of my first thoughts was, can we use it to make PCBs? In other words, if we take copper-clad board with etch resist on, can we burn through the etch resist and the copper track, effectively cutting out the space between the tracks? But when we tried that, and I want to show you actually, this is the results of the test. So we were first using the laser. You can see this is actually a scrap T-con board, and what I had in mind was to effectively cut into here a PCB tracks and then remove the etch resist where we can solder and just solder components onto it. But what we found is, because the copper is very reflective, once it cuts through the etch resist, even with several passes, it won't cut into the copper.
Yeah.
Yeah. So the idea is now, and I've ordered some ferric chloride, so this is etching solution, and we're going to make another video effectively with some scrap board like this. We can draw out the PCB layout that we want for a simple circuit, and then we can use ferric chloride to etch away where we have burnt through the solder mask, and we should be able to make a working PCB SMD on something like this. If that works, we can easily get from AliExpress. You can buy
the copper clads, yeah.
Yeah. So yes, thank you. Yeah, we can buy the copper clad boards. We can spray on. In fact, Carlos will talk to you about it in a moment. He did a little bit of reading up on this, but we can put effectively the etch resist on and then cut through that to make our pattern and again make the PCB. So what did you find out about that, Carlos, when you looked at it?
Yeah, the process is quite unused on the internet. There are a few creators that have done it before, but the copper clad, if you don't spray paint it, it will etch out everything, obviously, because it eats copper.
Yeah.
But spray paint is extraordinarily or really good at resisting the etchant. So they actually recommend spray paint, and black one as well, because it burns off easier from the laser, because the laser doesn't reflect as much light. So I was thinking of, we take some copper clad, just spray it black, and, and burn off what we don't need, so we have tracks. Pretty much my idea.
And then literally put it in the ferric chloride solution.
Yeah.
Give it a good swirl around.
Yes.
And we should end up with our PCB.
They recommend a sponge as well. Obviously, gloves, and be careful because it's corrosive.
Yeah.
If you're going to copy this.
Yeah, don't put your fingers into it. No. So that's something we're going to do on another video. I actually have the etch resist coming. It's coming this weekend, so we can have a play with that. Carlos, what do you think of the cover that we put over the cover they sent us?
The cover is really nice quality. The problem is the price. It's 160 euros almost, and you could do the same job with a cardboard box on top. The only reason you would buy it if you're using the machine in a work environment where there's a lot of people that can look at the laser. And the only time that you're actually in risk of getting a laser, eye full of laser, is when you are etching something reflective, like let's say PCBs or stainless steel, because it can actually etch stainless steel, and some other maybe clear acrylic could be one that can reflect a lot of light. So, but actually, if you're burning wood or cutting. Yeah, PCBs maybe a fringe case. I'm not really sure if it's going to reflect a lot of the light.
Okay, but this did come with some green. I won't call them sunglasses, but it came with some green protective glasses.
The protective glasses are exactly made for this wavelength of laser, and actually the laser becomes completely transparent when you use them.
So you don't see the laser?
You don't see the laser. That's probably why they chose on the laser head. Let's see if we can move it in frame. The head has a small shroud underneath. You can't see it right now, but it's red. But that's because they don't want to block out all the laser light, just the dangerous one, so you can actually see the laser point. So when you're centering the machine for cutting and stuff, like I showed you in the video, it will actually be visible to the naked eye. Because if you use the glasses, you won't see the laser and you won't know where it is.
True. Yeah, so you really need that to line it up on when you have the item you're working on, so you know where it's going to... where the limits are, the edges.
Yeah, exactly. Most laser programs have something that's called framing, so it goes around what you drew. So it goes around and shows you exactly where it's going. And some of the laser programs actually have the option of putting on the laser at low power to show you exactly where the beam will hit. So that will give you an indication of how big the thing is.
And Carlos, did you try the roller that came with this that allows you to print onto cylindrical objects?
Yeah, I did try it out, but I couldn't get it to work. I don't know if it was software or hardware, because I plugged it in like I saw in a few videos, but it didn't move. It didn't roll the thing. Maybe the thing I put on was too heavy. It was a normal mug, because it showed you could etch mugs, so I was thinking of making one. But I couldn't get it to work, so I'm going to do some more research, and when I know more, I'll make a video about the roller as well.
Yeah, as a separate, because that is a separate item when you buy these.
And it's quite expensive as well, so it's only for people that want to make engrave mugs, bottles, and I can't actually think of anything else.
You would use it for.
Yeah.
So I mean, this is the 10 watt laser. I mean, would you recommend this model? And there's a 5 watt version. I think there's something like a 1.5 or 2 watt version.
Okay, so for the difference in the price, the 5 watt is about 220, and this one is 300. For the difference in price, the 10 watt laser is well worth it.
Okay, so really it's sort of €300 for this setup.
Yeah, this one without the shroud is about €300, and it comes with the glasses. It doesn't come with a bottom plate, but you can actually make one with scrap MDF and cut in.
Yeah.
So that's not an issue. The actual base is quite nice, because if you cut through and you have, let's say, nothing underneath, you will cut through your table.
Yeah, but that's about €70 or something.
Yeah, €70 for the bottom plate, and I actually recommend it because it's quite nice quality, and it's really thick, and it's aluminium, so it won't break ever. Yeah,
but they cover it
170. That was a little excessive. I know why, because it has a laser-proof plastic window, and it has reflective covering that's fireproof. So you can actually leave the machine on and just go away.
Yeah.
And it won't burn up your house. I would never recommend you to leave this machine and just walk away.
No. But
it's still a laser.
That gives you some protection.
Yeah. Because if it starts burning, the only thing that actually can burn is the table underneath, but it will get suffocated by the actual shroud. And the smoke, so it would turn off the or extinguish the fires by itself. Yeah. So I think we've covered about everything we need to at the moment. With this, we will be using it again. I'd like to thank ComGo for giving me the opportunity to review this laser. I'd like to thank Carlos again for helping. It's really nice to work with Carlos. If you guys have not been over to Carlos's YouTube channel, it's called Retro Upgrade. I will link it from the description of this video. So get over and see Carlos. He has a lot of... I kind of say Carlos and myself, we have a lot of the same interests, but we have a different skill set. I'm a little more of building and designing, and Richard is more of a fixer, but we both fix things, even if we have different skill sets. I fix the things that Carlos built. We overlap a lot, actually. We do. Okay guys, so thanks for watching, and we will both see you soon on another Learning Electronics Repair video. Ciao for now, guys. Bye, guys.